Alrighty, so we are going to start with the 5.7 homework questions that were 23, 25, 27, all very, very similar. So I'm going to just do 23 kind of as like the whole thing done out. Then we'll talk about 25 and 27. I might use some of the graphing software that I showed you. We had 33, which I'll do, and then of 43 and 45, again, very, very similar. So I might just do 43 and then I'll talk about 45. So the first one we're going to start out with is 23. So let's grab that one here. So again, we are going to start out with this one. In terms of graphing this thing, it would be helpful if I could grab a pre-existing graph to try and make my work look remotely nice. So we will do this. And that's what we'll do for our actual graph itself. And now when we're doing a problem like this, basically what I'm trying to do is I'm trying to graph my quadratic, and then it's got an inequality instead of an equality. So the difference there is before we were doing like linear equalities, it was just a line. And linear inequalities was either a bold or a dotted line, and then I shade part of the thing. So when I'm looking at this, I'm saying, okay, y is greater than or equal to. So the greater than or equal to part of this means it's going to be a bold line. So this is just going to be a bold, and when I say line, I mean curve. It's going to be a bold curve here, so it's not going to be dotted, versus if I was doing number 20, that would be dotted because it's a strictly less than. If I was doing number 19, it would be dotted because it's strictly less than. 25, strictly greater than, so again, dotted, versus 22, 21, 24, all of those are going to be bolded curves. So when I'm looking at this, it's going to be bold, and then I'm looking at saying y is greater than this thing. So what that greater than means is that since I have y greater than or equal to stuff, basically all I'm saying is I'm going to be shading above. So shade above can look two different ways depending on how the curve is opening, whether it's opening up or whether it's opening down. So at a very high level, if I had something that looked, let's say, like this, and I was going to be shading above, I'd be shading all this stuff up here. But if I had something that looked like this, and I was shading above, it would look like all this stuff shaded in here. So again, it's going to just still be above. It's just depending on whether the thing opens up or down, and that's the A value. My A value here is a positive 2. So this thing looks like it should be opening up. Maybe there's some shift or whatever like that. We'll get to that stuff in a second. But for the most part, it should look like something like this. So let's actually start. And the way that I would start graphing this thing is I would say, okay, does it look like it's in vertex form? No, it doesn't. Well, okay, I'll just do a little bit more work. This to me looks like it's in standard form. I know how to graph something in standard form. If I have it in standard form, it's basically saying it looks like y equals ax squared plus bx plus c. My a value here in this problem is 2. My b value here is -2. And then my c value is -5. If I wanted to complete my square and put this into vertex form, I absolutely could, but I don't need to. If I wanted to graph something from standard form, what I would do is I would take -b divided by 2a. And the reason I'm doing that is that gives me my x coordinate for my vertex. So in this problem, it's going to be negative of -2 all divided by 2 times 2. Okay, cool. So when I'm doing this, this is going to give me a 4 divided by, oops, that's not true, getting ahead of myself. Gives me a 2 divided by 4, which is 1/2. So my vertex for this thing has 1/2 for the x. So when I'm looking at my vertex, so far I've figured out that it's going to be 1/2, comma, something. The something is going to be when I take 1/2 and plug it back into my function. So I'm going to plug it back in for my x values here. So let's take the 1/2 we have, and we'll plug it back in up here for my x's. So now I'm going to say y is going to be 2 times 1/2 squared minus 2 times 1/2 minus 5. So 1/2 squared is 1/4. So I'm going to say 2 times 1/4 minus 2 times 1/2 is just 1, minus 5. 2 times 1/4 is 1/2, minus 6. I can change this to being over 2 by multiplying by 2 over 2. I'm actually going to do that in another color just so we can see that. So I'm going to change this to, again, just being 1/2 minus, I'm going to make it look like 6 over 1. And then I'm going to be multiplying by a clever 1. So I'm going to make this look like 2 over 2. So I got 1/2 minus 12 over 2, which will give me negative 11 halves. So now I have my vertex for this thing. And then in all the problems that we've been doing, we've moved from the vertex out 2 points to the left and 2 points to the right. So by adding 1 and subtracting 1. So if I were to draw this out, t-chart like we typically have been doing, I would say my x's go here, my y's go here. I start with the vertex thing that I've got. So let's say we have our 1/2 and negative 11 halves here. And then from here, I'd move 1 to the left, so it would be negative 1/2. And then here would be negative 3 halves. If you wanted to use decimals for these, that would be fine as well. This is negative 1.5. Oh, really getting squished there. Sorry about that. And then over here, this is just negative 0.5. Here, this is obviously just 0.5. And this is negative 5.5. For this problem, if you want to use decimals, it's totally fine. There's no rounding issues. It's an exact decimal, so I'm okay with that. Here we would have 3 halves and then 5 halves, which is the same thing as saying 1.5 and 2.5. And so now I'm going to actually plug these values in. I'm probably not going to step through like every single one of these. We should also know that when we see this, we're going to have some symmetry between the points. So like when I'm looking at my equation here, I'm basically saying like, where is this going to look the same, right? It's going to look the same reflected over my axis of symmetry. That axis of symmetry goes straight down through the vertex. It's x equals, whatever the x coordinate for the vertex is. So my axis of symmetry here should be x equals 1/2. So that's basically going to reflect all the points that I do on the left with the points I do on the right. Now, what I mean by that is that wherever I am shifting, if I go 1 to the right, that y value is going to be the same as if I shifted 1 to the left. So when I'm plugging all these values in, I'm really only going to do it one time for each. So I'm going to only be doing like for either this one here or this one here, or I'll do this one here or this one here, because I don't really want to do it twice. I'm super lazy. I mean, don't tell anybody, but like, that's the truth of the matter. So basically when we're doing these things, we're going to start out by just plugging these values in. And so we will start with our negative 1.5 back into our equation here. So let's pick another color we haven't used yet. I don't know what this is, blue-gray. Let's try out blue-gray. So here I've got 2 times, and then here's my negative 1.5. If you want to use the fractions, I'd recommend using fractions. So why am I doing it with decimals then? So this is my negative 3 halves, and I am squaring that thing, and I'm saying minus 2 times my negative 3 halves, and then I'm saying minus 5. So the first term here, the -3/2 squared gives me 9/4. 9/4 times 2 is going to give me 9/2. So I get 9/2. And then I got minus 2 times -3/2. So this negative and this negative are going to cancel out, so it's going to be a positive. And I'm saying 2 times something which is divided by 2, so that cancels off. So this is going to be plus 3. And then here I've got minus 5. So 3 minus 5 gives me -2. So I'm basically just saying 9/2, and I'm saying minus 2. So when I do that, I'm basically saying 9/2 minus 2 will give me my 5/2, because I'm going to convert that. I don't want to run out of space here, but we'll do 9/2 minus 4/2. So again, I'm subtracting 2, but I want to make it look like halves, so I'd multiply that by 2/2. So this is just another way of writing minus 2. So now here I get 5/2. And if you want it as a decimal, it would be 2.5. So now as my coordinate here, it'd be -3/2, comma 5/2 as what I'd be putting on my graph here, which we'll see in a second. So I would go through, I would do the rest of these points. I'm just gonna enter the values in because I want to save us some time and just skip to the good stuff here. So this is gonna end up being -7/2, which is the same thing as -3.5. And now here's where we get to the part where being smart and lazy really is coming in to save us here. So this is going to be the same as over here, and this is going to be the same as down here. Again, reflected symmetrically over that x equals, and then my vertex here, x value. So x equals 1/2, like a dotted vertical line here. So I'm going to be able to say this is -7/2, and I'm able to say this is 5/2. So now with these points, I'm just going to graph them. So let's do orange for graphing here. They don't need to be super, super perfect, so don't worry about that. So I got 1/2 and then -5.5, I don't know, puts me somewhere like that. And then I'm going to go one to the right here, and I end up being at -3.5, something like that. And then I go one more point to the right to approximately here. And then again, reflected symmetrically. So we've got our other point here and our other point here. And now let's talk about what this thing actually looks like. So now when I'm actually drawing this thing, again, we said it was going to be bold. So this thing, again, something like this, coming up like that. Okay, cool. It may look like a V, and that's totally fine. We're not here to judge artistry. But what I am looking for is a curve. It should not be like a line. So don't think that this slope is going to be constant for this whole function, because that would be linear, right? This is a quadratic, so this thing has a curve to it. It doesn't need to look like it has a great curve. It looks like a V, whatever. I'm more concerned about the points. From here, we said we have to do some shading. And so here we said we're going to shade above, right? Y is greater than. So in terms of what I'd be looking for, let's just graffiti this thing up. This whole region in here should be what I see shaded. So this is what I'm looking for a final answer, something like that. If I wanted to test one of these points, I absolutely could. So let's say I was really curious, right? I'm like, okay, I think it's in this top region here. Let's pick a point which is super obviously there. Anything directly above your vertex is good. I'm just going to scoot a smidge over to the side because I love plugging in 0. So I want to see if this point works. I want to see if 0, 0 works. If I plug in 0 here, 0 for my y, 0 for my x's, 2 times 0 squared is 0, minus 2 times 0 is 0, minus 5 is -5. Is 0 greater than or equal to -5? Yes, yes it is. And that's why it's part of this shaded region here, because all of these points work for this equation. Let's pick something that doesn't work. So over here, if I picked 0, comma, -10, right? If I plug 0, comma, -10 in, I'm saying -10 is greater than or equal to, and I've got 0, 0, -5. Last time I checked, -10 was not greater than or equal to -5. So this point does not work. Green is good, red is bad, and orange again is the graph that I'd want to see for this. Any questions here? Perfect. All right. Let's wipe this stuff out and we'll talk about 33. So 33 looks like this. And again, I might kind of skip a little bit in terms of like doing every single one of these points out, and I might do it entirely in the graphing software rather than do it here just to save myself some time and effort, because the steps are exactly the same as the last one we just did in terms of like graphing these things. So let's just high level talk about what it is we're starting with. So we're doing 33 now. So this is the one we're working on. I'm going to do the top equation here first in red. And so let's talk about how we would go about trying to graph this thing. So again, this thing is in standard form. We could change it if we wanted to, or we could just deal with it in the standard form. The first thing I want to do is do the negative b over 2a. Go ahead and solve for the x from my vertex, and then go ahead and plug it in, set up my t-chart, blah, blah, blah. So exact same steps that we did before. That's why I kind of went a little bit more detail on the last one. So let's notice the actual difference here in the inequalities versus the equalities that we have been doing in 5.1 earlier. So here we're saying y is less than this thing. So less than means I'm going to be shading below, and it also means that this is going to be dotted. Okay, so it's strictly less than, dotted, dashed, twinkled, however you want to think about it. This is going to just not have a bold curve. And the reason is it cannot equal that value, right? So if I had 0 is less than 0, is that true? No, it's not. 0 is not less than 0. 0 is less than or equal to 0, but it's not strictly less than. So that's why we have this dotted thing here, is it's saying we can get really, really close, but we can't actually be on that curve. So that's the first one we've got. And then the second one we have here is y is greater than this thing. And so now we're going to shade above here. And it's going to be bold. So again, because it's or equal to, it will actually occupy that curve itself. So when we're looking at these two things, I actually think I want to do this in the graphing software just to get you guys some exposure there. It'll also look a lot cleaner than me actually, doing it out here. So we go to Desmos, we go to start graphing. Apologize for flipping back and forth here. Let's see, so y is less than. If you want to use the shortcut on your keyboard of Shift and then 6, which is that little caret up key, it'll bump you into the exponent. If you don't want to do that and you're more comfortable using the keyboard they provide, you can use this as well. So right at the bottom here, keyboard, shrink, expand, cool story, bro. All right. And now I'm going to say what, plus 2x minus 5. Oopsie, there we go. So this is what my graph looks like. I'm going to zoom out a little bit to capture the bottom of that vertex. So this is what it would just be if it was a single thing, but we don't have just a single thing. Now we also have this y is greater than or equal to, so we're going to make a second one here. Y is, and now I'll have to use one of these keys, greater than or equal to, what was it, 2x squared, oh, it's negative, my bad. So let's stick a
Wait,
negative
Mr.
out in front
Goldberg,
here. Yeah.
are we allowed to like use Desmos when we're graphing stuff? Or like
Yeah,
to
like if
help
you're doing your
out?
homework and you want like yeah, absolutely. As a tool, I would definitely encourage you guys to use Desmos, and that's why I'm including it like on these documents. Like when I put like 5.8 lesson, 5.7 lesson, I put links for it right here. So graphing software to help you guys. I understand that some of you do have graphing calculators, but maybe not all. So I definitely want us to be able to utilize different tools online.
Okay. Thank
So
you.
yeah,
Sorry. I
absolutely.
just wanted to make sure because,
No, my pleasure.
yeah, okay, thank you.
Yeah, no, good question. Good question. So now I've got something that looks like this, right? And so what is my actual like bounded region here? It's a little bit tricky to see because the shading, I think, could be a little bit more exaggerated, but it's not quite. So this whole thing below here is not included. This thing above here is not included because I'm shading below this one and I'm shading above this one. Okay, so what that means is that this whole part on the right and this whole part on the left are going to be my shaded regions. So in terms of like one level of shading, yes, this works for the blue thing, but it doesn't work for the red. And yes, this works for the red thing, but it doesn't work for the blue. So when you guys are graphing these, I'm going to do just like the quick sort of comparison in paint here. So let's switch back and forth. I'll try and keep the same colors too. So we got red. I don't know, something like this. All right, so we can graph it, but it looks something like that. When I'm graphing this thing, the first thing I would do is I would just do my little kind of wiggle shading underneath. So again, just to note that I'm below this thing, I'm just wiggling it. And then for the blue, I'd do the same, but blue is going to be, for us, it was green here, so I guess I'll do it in green, that I'm going to be going above this thing. So again, I'm just trying to like ballpark, what these things look like. Again, don't take this to be accurate. Clearly, it's not my best work. Shading above for this stuff. So on a test, like if I see this, that's great. But then in terms of a final answer, what I would want to see is the actual like shading, something clearly indicating that it's this stuff over here. And then if you want to like, give it a little extra, that's great. And then something clearly indicating it's this stuff out here and give it a little extra. That's what I'm looking for. So again, I want to see like, a little bit of line there, and that's how I would show it versus like how they're showing it. Clearly they have like better rendering software for that shading than I have with my, rinky-dink pencil or whatever I'm using. Does this one make sense?
Yeah.
Really the only new concept here is that I'll have them overlap.
Okay, so I had a question. How do you want us
Yeah,
to like graph these inequalities in our homework? Do you just want us like to draw a plus sign on the paper and just draw it in?
it should look something like this.
Yeah, I know, but how do you want us to like put it on the paper? Do you want me to like draw it on graphing paper and just post that too? Would you like me just to
Yeah,
draw
if you
a plus
don't if you don't have graphing paper, it's not the end of the world. You can just do it on normal paper. And again, the T-chart would be something I'm more interested in, like on a test sort of thing.
sign? Okay.
Does that answer your question?
Yeah, it does. Thank you.
Cool. Yeah, my pleasure. What else do we have for 33? Good, good. All right. So let's talk about 43 now. So 43, if I were to wager a guess, would have been one of the things that gave people more trouble. And so let's talk about this one in detail. I may show you a solving method here, which is slightly different than the videos that you saw or found yourself, and that's totally fine. I'm just going to show you my preferential style for solving this, but there are a couple different methods you can use that'll get you the right answer. So the first thing that I like to do with these is I like to pretend, what am I doing, 43 to start? Okay, so 43 is quick and easy. Like it'll be a very simple version of like what these things will look like. Is I like to say, okay, well, if I'm trying to solve this inequality, I can basically treat it as if it were an equality, and then I want to see where my actual like region would be, right? So this is going to change whether it's shading above or below. So for this one, it's below, but I'm going to just treat this as if it were saying 4x squared was equal to 25. And I'll explain why that is that I'm doing this. So the reason I'm using this actual thing is, where it's going to hit on the curve itself, right? This is like not the bounded region part of it where I'm shading, this is like just the curve itself would look like this. So I'm trying to find zeros here, because essentially all this is saying is where are my zeros going to be? So when I'm solving this, I can either just solve it like this, or I could subtract the 25 over and then solve set equals 0. I personally am going to solve this by like the method I think we named is like taking the square root, right? So I want this thing by itself. If I wanted to subtract 25 over and to do my difference of two squares, totally fine to do it that way as well. Either way will, again, bring us to the same spot. So let's do divided by 4, divided by 4, x squared equals 25 over 4. So now that I've got 25 over 4, I'm going to take my square root, take my square root. Anytime I take a square root, again, we're going to have that plus or minus. And here I'm just going to leave it as 25 over 4 just for one more moment. Then we're going to simplify this thing. So now I'm going to split my root into, I have root 25 on top, and I've got root 4 on the bottom. These happen to be two very nice square roots. Thank you, math. Oops. So here I get 5 and 2. So now what I'm going to do is I'm going to set up what sort of is like the line graphs we were doing before when we're talking about like inequalities for like absolute values and things like that. So I'm going to set this up to look like this. Okay, so here's my line. It's clearly a great line. There's no curve to it whatsoever. Greatest line that's ever been drawn. And now I'm going to put the 2 points. So one of them is going to be negative 5 over 2. And one of them is going to be positive 5 over 2. Now, my inequality sign is going to determine where I'm going to be, whether I'm going to be within these things or outside of these things. It's only ever going to be one of two things, okay? So I'm going to say option 1 is going to be inside, and it'll look like this. Again, because it's a strictly less than, I'm going to have open circle to open circle, and then option, oops, I should switch colors here. I'll say option 2 would be outside. So it would look like this, opening to the left, again, shading all this stuff here, and it would be this opening to the right. And again, it's going to be all this stuff here. So these are my two options, and I'll show you based on the sign what it's always going to be, and we can kind of like learn that, or we can just kind of figure them out as we go by testing values. I'm going to show you by testing values because I really don't want you guys to feel like you're memorizing one thing or the other. Although if you do a couple of them, it hopefully becomes intuitive. So the thing that I'm going to do is I'm going to pick a value. So I'm going to take blue, and I'm going to pick a value somewhere on this graph. Okay, I'm just going to do for all three regions to demonstrate for you that once I figure out one, I know the rest, and it really doesn't matter. My favorite thing to plug in is 0, so I'm going to plug in 0 because I'm lazy. Over here, I need something bigger than 5 halves. It really doesn't matter what it is. I'm just going to pick 10. Okay. Over here, I'm going to pick something. I'm going to pick negative 10. Now, this isn't drawn remotely to scale, and that doesn't matter at all. I'm okay with that. If I plugged in negative 10, what would happen? So I'm going back to my equation. I'm saying 4 times negative 10 squared less than 25 is 4 times 100 less than 25. Last time I checked, 400 is not less than 25. So this one is a no. It does not work here. Okay, well, let's try another one. Let's try the 0. So here was plugging in for negative 10. Now let's plug in for 0. 4 times 0 squared less than 25. Last time I checked, 0 squared is 0. 4 times 0 is 0. Is 0 less than 25? Yes. So here it does work. So I'll put a little check mark there. Cool. And then we'll do it one more time, although we have our answer already. So plug in negative 10. 4 times 10 squared less than 25 is 400 less than 25. Nope. Nope, where's Michael? Don't think so. So basically when we're doing this, we've got this pattern that emerges, and here we're outside, or excuse me, we're inside. So we're using option 1, which is that my values are inside, and the reason being is that this thing is less than the value. Okay, so when we're doing this, you'll see this pattern emerge, but the thing that we can always do is test a value, right? So if it works here, it'll work here and here. If it doesn't work here, it means it will not work here, will not work here, and it will work in the middle. If it does work in the middle, again, it will not work on the outsides. If it does not work in the middle, it will work on the outsides. And vice versa over here, same as we had over here. If it works here, it works here. If it does not, then it will not here and here, but it will work in the middle. So it's always one or the other, whether it's going to be orange or red here. Any questions on this one? Perfect. All right. So the only thing that's different about this
Mr. Goldenberg.
in 40, yeah, what you got, Damon?
Wait, so the answer for that one would be 0?
Oh, so yeah, let's actually write out our answer. Thank you. So my answer is this whole region of values here. So this is what I want, is this whole region between here and here. So how do I actually write this as an answer, right? So if I had a little bit running out of colors, we haven't used this yet. So let's say I'm saying, okay, this is my actual like graph version of what this thing looks like from negative 5/2 to 5/2. So now when I'm looking at this, how do I actually represent this? I'm saying x is less than the thing on the right, which is my positive 5/2, and then is greater than my negative 5/2. When we're writing these things out, I would always write out the pieces, write out the pieces, write out the pieces, and then connect the signs. This is the final answer I should see. If it said solve and graph, then this is what the kind of graph would look like. But this is my final answer here. Thank you, Damon. What else we got here? No more questions on 43? Alrighty. So I'm just gonna, oops, I don't need that. I'm gonna talk about 45 real quick here. So for 45, I would talk about like, how is it that I can get this thing to equal 0, right? If I had an equation I was trying to solve, this is equal to 0, I have it set up, all it needs is either the quadratic formula, negative b plus or minus 4ac all divided by 2a, or I can actually see, does this thing factor nicely? If it does, then I can factor it, and I can set those equal to 0 and solve. Again, those zeros give me the points that I want. So 45, super similar to 43, just you have to solve the zeros and the numbers are different. Any other questions from the 5.7 homework before I wrap this up? Perfect. All right. I will stop the recording here.